Alright, so in this recording I'm just going to provide a quick intro to doing structural analysis in ANSYS. We have these two hook files, 7-ton hook, that will do a stress analysis. In class I went through going through version 1 and 2, but for the sake of this video I'm just going to do the second version of this hook. So what I need to do is just download that. So I'm just going to save that file. It's going to be in my downloads folder. So I'll use that as my geometry. That file is a step file. It was created in SolidWorks. Step file is a universal file format that can be opened by ANSYS. I'm going to open ANSYS Workbench 18.1, and this is available in the ITSS labs. I've added a link to the Moodle site which shows you how to run this software on your own computer remotely. Okay, so I have the hook downloaded. ANSYS is loading here. Alright, so ANSYS is loaded. So the first thing I want to do is I have this schematic view, which is where I set up my analysis, and we'll work with this as we go along in the semester, but for this exercise we're just doing a static structural analysis. So we take these analysis types and we just drag those onto the schematic. So for static structural, I'm going to click and drag and drop that on onto my schematic. When you click and drag something, it'll just give you red boxes or green boxes where you can drop it, and you can only drop it in those locations. So I have a static structural. If you have something you want to delete, just click the upper arrow there. It may take a little bit for that menu to come up, and you just hit delete and click OK. So I'm going to drag the static structural onto there. First thing I want to do is just save my initial workspace here, so I'll hit save. When you're working on the ITSS computers, it's important that you save the file to your local computer. You don't want to save it to a USB or network drive while you're working with it. So I'm going to save it to the desktop. I'll create a new folder. ANSYS example on my desktop. And I'll just name the file example. So when I do that, if I go into that folder, what it does, it creates this Workbench project file. Now when you upload your projects or your homeworks, you don't want to use this as your file for you don't want to upload this file. You want to make an archive file, which I'll show you how to do in a second. It also creates this folder that goes along with your analysis. The problem, if you upload just this file, it won't have the geometry or any of the files in this folder along with the file, so you need to create an archive file for what you upload. So to do that, you do file, after you save it for the final time, you do file, archive, and I'm going to put that in the same directory, but example.workbench wbpz workbench project zip file. What that does, and here I want to unclick results, but click include files external to the project, and what that'll do is that step file I'm going to add to this project will include that. So I create an archive file. Now obviously I do this after I'm done with everything, but when I upload it to the Moodle site, and it should, I think I placed it in that folder. Let me try that again. File, archive, desktop. I placed it in a different folder. Let's put it in the example folder I just created. So when I look in that folder I just created, I'll get this Workbench project zip file. It has a zipper on the icon. This is what you'll upload for your homeworks to the Moodle site. Also, when you're done working, you want to create at the computer, you want to create an archive file, and the archive file is what you're going to copy to your USB drive or your network drive so that you don't lose any of your work. So anytime you're done with your session of working, save your schematic, file save, and then do file, create archive, and then you'll be able to save your work and take it to a different computer. If you just take the project file, you may lose some of your work. And even if you take this whole folder, this is ANSYS example folder I created on the desktop, I may lose, still won't have that step file in it. So the best thing to do is create the archive file. So now I need to import that step file. So I right click on geometry to import the step file. So I do import geometry. Now when you first right click, it's going to be some delay before that menu comes up. So just wait for it, especially on the lab computers the first time you do it. Just wait for that menu to come up, because if you keep clicking the right mouse button, you'll make it go away. So right click geometry, wait for that dialog to come up. Do import geometry, and here I'm going to browse. I know it's in my download, so I'll click downloads. I'm going to do hook. I'm just going to start with hook version 2 step file that I downloaded from the Moodle site. Once I have that file, I can double click on model. Now allow me to set up my finite element analysis. You see it's saying starting mechanical on the lower left. Whenever you double click something and it's taking a while, just look on the lower left. If you see this red light, that means it's starting a different part of the program, and sometimes that will take a while. So it's loading that step file. So this is the hook. Now by default, ANSYS always assigns the material as structural steel. But here this part's actually would be cast iron, but cast iron and steel have the same elastic modulus, so we're okay to leave this as structural steel. Our displacements and stresses will be the same. So I'll leave that as structural steel, and in the next video example we do in class, we'll talk about how to set different materials. But here I'll just leave it as structural steel, since I'll get equivalent results. You can see it has question marks where you need to add setup options. So for the static structural, I need to apply boundary conditions and apply a load. Now keep in mind this menu up here, you'll notice that it's changing as I click on different things. And if you're ever looking for a menu option and it's not showing up on this bar up here, it's most likely you're not clicked on the right thing in this feature tree. So I'm going to click on static structural. That's going to allow me to apply loads and boundary conditions. So I'm going to do supports, which is going to be my fixed boundary condition. So I'm going to do a fixed support. I'm going to do a fixed support where this hook would hook to a chain on this bottom surface. So it's by default highlighting this geometry, which is asking for me to select the surfaces or lines or edges or points I want to apply the boundary condition. Now up here, one thing that's unique about the way ANSYS works is that right now it's only letting me pick surfaces. You have this selection filter up on your toolbar. If I wanted to pick edges, I would pick that icon. It would allow me to pick edges. If I wanted to pick points, I pick that icon, allowing me to pick points. If you're ever unable to pick what you're wanting to pick, it's probably because you have this filter on the wrong setting. So here I want surfaces. I want this bottom surface, and I click apply. What that does is it assigns that surface as a fixed geometry, meaning that it has zero displacement boundary condition. So now that adds that there. Now occasionally you may forget to hit that apply button, and this will show as a question mark next to it. You'll just have to go back into it, click this geometry, click the face, click apply again to make that assignment. And it'll show up as yellow if you have not assigned it. I'm going to do loads. I'm going to apply a force. This is a 7-ton hook. That's about 60,000 newtons, so I'm going to put a 60,000 newton load in the negative Y direction for this part. So to do that, again, I got to be clicked on static structural, do loads, force load. I created these 4 areas to apply the force load. And that's the main difference between this hook 2 and the hook 1. So here it allows me to distribute the force over an area. So I'm going to click. Now to do multiple selections, you have to hold down the control button. So hold down control key as you're clicking, and you can do multiple selections. I'm going to hit apply to apply that geometry selection. Okay, now it's showing as red. Now by default it allows you to do a vector. What I want to do is in the negative Y direction, so the way I do that is click on this vector and switch it to components. That allows me to do it in a coordinate system. By default it's using a global coordinate system, which is shown on the right here. I want in the Y direction to be negative 60,000. And right now my units are in newtons, so negative 60,000. You can change your units up here. The part will be ANSYS will make the unit conversions internally to make everything correct. I have it as millimeters newtons. I like to do millimeters newtons because then my stresses will be in megapascals. Now it has this checkbox next to the Y component. Right now we don't need to check that. If you check it, it puts a P in there, which means it's parameterized, and you can use that for optimization and design studies. We'll look at that later on. Right now I want to leave that unclicked. The problem here is if you change that to check, you can't change the value here, so I'm going to uncheck that. So that checkbox is unchecked. So negative 60,000, you can see a verification of your force on the screen here. So now all the question boxes are gone. I had these yellow lightning bolts. It just indicates I need to solve to get a solution. So I'll hit solve here for this problem. And I haven't specified anything with the mesh. It'll do a default mesh size for this model. So right now if I click solution, there's nothing showing here. I haven't created any result plots. If I click solution information, it does give me the output of the solver. Usually I don't need to look at this, though occasionally if there's an error it'll show a red icon next to the solution. I'll have to take a look at the solution information and usually look towards the bottom. It'll say the word error with asterisks before and after it. If you see that, it sometimes give you an indication of why the solve didn't work. Now I need to add some solution plots. I'm going to add a deformation plot. So total deformation. Again, I need to be clicked on solution to get these plot options. Deformation plot, total. And now it has the yellow lightning bolt. This means I need to click solve again. It's not actually going to solve it. The solution's already there, but it's just going to create the plot. So I have the deformation plot. And if I hit play, it'll show an animation. Now this animation is exaggerated displacement. Right now it's set upper left. I can set the scale. It's defaulting to a scale of 10 just to exaggerate so I can see the deformation. I can set it to true scale, which would be the actual deformation, but this part deforms very little, so that's why they have the automatic scaling, okay, at a larger value. So I hit the play button to see the animation. Now what I'm interested in is stress to see how close this part is to failure. So I want to click on solution again, do stress. I'm going to look at von Mises stress. There's one thing I like to change here, and I'll ask you to do it in your homeworks typically. I'm going to switch from display option from average to on average stress, and I'll show you what that means in a second here. And we'll learn more about that as we learn more about the theory of the element interpolation. So again, I got to update it to see to create that plot. Now when I'm on average, you can see that I see discontinuous stress across element boundaries. And as we'll learn in class, this is an indication that the stress is not converged, that my mesh is not small enough to accurately capture the stress, because the stress would not be discontinuous across element boundaries unless there's a transition of material stiffness. So here we know that we need to refine the mesh to get an accurate solution. You can see the scale here. I can click the max. It'll show me where the max stress is. And the max is 673 megapascals. But I know I need to refine this mesh further to get a more accurate solution. I can also use the probe tool, and I can click anywhere to get the stress value. Okay, and to delete those probes, the only way to delete them is to either regenerate the plot, or if I click this icon up here, it allows me to select labels. It's in that selection filter area. And I can hit delete. I can select them and hit delete to remove any labels that I don't want. Okay, and to remove the max, I just toggle this button. Okay, so I know I need to refine the mesh a little bit. Oftentimes before I refine the mesh, I like to know how big the mesh currently is. So to do a measurement, there's not really a measurement tool, so you have to base it on selections. So if I switch, I want to select two adjacent nodes and see how far apart they are. That'll give me a sense of the current mesh size. So in order to select, right now it's not letting me select nodes. So again, whenever you're unable to select something, look up on your selection filters. I want to select nodes. Allow me to select nodes or elements. So I'm going to click two adjacent nodes. And again, to click two nodes, you gotta click Control, hold Control. Now down here, it's showing me a window that shows a distance between those. Right now my element size is about 16 millimeters. Now, you may not see, by default this window does not show up. To show that window, you have to go View, menu down to Windows, and turn on selection information. So if I turn that off, this is what the default view looks like. I don't see anything about the distance. So I go to View, Windows, Selection Information, and now that gives me the distance between those two nodes, which is 16 millimeters. So it gives me some sense of the current element size. So if I click Mesh, I'm going to make that element size a little smaller just to see how that affects the result. So I'm going to do sizing. And I'm clicking on Mesh on the feature tree, going to sizing, and right now this feature it's just a default size, so it picks some size. I'll set 5, and my units are millimeters. Now keep in mind the default units are meters, so then you'd want to put 0.005 just to make sure you get the right size. So, so I have 5 millimeters there. So now if I hit solve, and it's showing me that mesh needs to be updated. So if I right click the mesh, I can either hit solve, it'll automatically remesh it, or I can right click the mesh and say generate mesh if I just want to see how what that mesh would look like with that new size setting. It's not changing too much, so let me actually drop the size a little bit more. Let's just drop it down to 1 millimeter, and then right click that and say generate mesh to see how that updates the mesh. Okay, so that's a little bit smaller. So now if I hit run, solve, it'll redo the stress analysis at this element size, and we'll see how continuous the stress is across my elements with that. So I click my solution again. I can see that my stress is a little more continuous across boundaries. My peak stress hasn't changed too much, 672 megapascals. But I can still see I have discontinuity across these elements, so I need to refine it further. So we'll see next time in the next video how to refine the mesh in just a certain area. We could refine the mesh on the whole model, but that becomes very time intensive and makes the model run slower and may not even bother run at all. So we really want to target where we refine the mesh. So the method I'll show you today is automatic mesh refinement. Works for simple models like this. As you get into more complex models, you tend to have to do custom mesh refinement like we'll do next time. Alright, so to do automatic mesh refinement, you click on the particular parameter you're interested in. Here is equivalent stress. So if I right click on that, and what I want to do is click insert. Now again, right click on my stress, insert convergence, and this will refine the mesh until the stress doesn't change by this allowable change criteria. So I'm going to change that to 10%. So I want to keep reducing the mesh size until it longer changes by 10%. The other thing you got to do is go to solution and tell it number of max refinement loops. By default it's 1, so it'll only do 1 run. But I want to allow it, let's just say do 3, and it'll keep refining the mesh. It'll do it up to 3 times to try to get convergence. So I'm going to click on my convergence here. It's showing red that it hasn't converged. That's because it's only done 1 run. It hasn't been able to calculate, and it'll keep track of that for you. So I'm going to hit solve. And what it's going to do, I'll move this little window, it's going to it'll run it, refine the mesh, make the mesh size smaller, run it again, calculate the change in max stress, and then when that changed, so the first change was minus 11%, so that's not quite converged yet, according to my criteria that I said of 10% change, plus or minus. So now it's refining the mesh again. The stress had went down a little bit in that case. And I get only a 2% change. Max stress of 586 is the final stress, so I can look at the equivalent stress plot now, and you can see now the stress is much more continuous across elements. So that's why I like to show on average stress. It provides a good visual indicator of how converged my solution is, and now I have pretty good assurance that my max stress is 586 megapascals for this particular loading. So now I'm done with the analysis for this example. If I were to save this, I want to save it. It's the same as, you can save it either from here or from the project schematic. It'll do the same thing. So I'm going to do save project. This updates that workbench project file that I created in this ANSYS example directory, so that's been updated. The other thing I want to do, if I wanted to work on a different computer or submit this as a homework, I go back to my schematic, do file, archive this. I'll just replace the previous archive I created, and I just replace it. And I don't want to put results in. I can always rerun it to get my results, but I do want to include imported geometry. So I click archive. And I'll just show you how to restore an archive. once you create the archive file. So I can just close this. There's a couple things I can do. I can do File, Restore Archive, and just click the one I had saved before. And I'll click, and it says, do you want to close the open file? And I'll say yes, I want to replace what I have open with the archive file. So now it's just reopened, but now it's open from the archive file. It's going to look the same because it's the same. So it does include solution, which, because I unclicked the solution box. And now if I double click the model, it'll reopen the starting mechanical. I can see that in the lower left. I can verify that everything is still there with my archive file. Okay, so total. So actually it has the stress plots. It just doesn't have all of the results in the database, but it still has my plots there. And I can always hit solve. So I think if I tried to make a new plot, like for example strain, you'd probably have to solve the whole thing. So I'd have to resolve this to get that. So I'd have to clear generated data and hit solve again. So right click. Whenever it gets in that state where it can't update the status of the model, if you right click static structural and say clear generated data, and then hit solve again, it should be able to create that new plot I asked it to create. One issue is I have this convergence check here, so it's still going to do multiple runs to verify the convergence. And as we saw before, it'll need to do one more run. So if you did want to save this time, you could include results, but for your homeworks I don't want you to include results because the files get to be too large, and now we have that strain file, the strain plot. The other way to open these archive files, if I just close out here and I don't want to save, I can just double click it from the File Explorer. Keep in mind, if you're on the lab computers, you do have to have launched ANSYS for the first time in order for it to be able to do this through the apps for you. If you try to do this before you launch it through apps for you, it won't know how to open the file type. When you use apps for you, each time you launch a program, it's like you're installing it on that computer. So this should open that up. I should see my project schematic. Alright, so this completes the that first tutorial, and the next tutorial will be for your first homework assignment.